Today we're going to be talking about autosomal dominant traits, but before we do that, let's go ahead and take a look at the following pedigree. Circles are going to be used to indicate a female, and squares are going to be used to indicate a male. Any place you see a shaded figure means that individual is affected. They have the trait of interest. These two individuals right here had kids. They had a daughter and they had a son. Both the daughter and the son had additional kids. The next thing we want to do is we want to label this pedigree. So we're going to go ahead and label the generations 1, 2, and 3. Generation 1 is going to be the oldest, and the generation 3 in this case is going to be the youngest or most recent generation. After we label those with Roman numerals, we want to label each individual with an Arabic numeral. So we're going to go ahead and do that. Arabic numeral 1, 2. Then we're going to start over. 1, 2, 3, 4. And again, 1, 2, 3, 4, 5. Now if I want to refer to this particular individual right here, what I'm going to do is I'm going to refer to them as 3-4. So Roman numeral 3-4. If I wanted to refer to this individual up here, Roman numeral 1-2. That's how we do that. Now we got to go ahead and we actually need to write the genotypes. But before we can do that, we have to actually figure out what's the mode of transmission, or what's the mode of inheritance here. So if you remember the flow chart I made earlier, the first thing we want to establish is this a dominant trait or is this a recessive trait? So, do all affected individuals have an affected parent? So these affected individuals have an affected parent. This individual has affected parents. So that is true. That means we're probably looking at a dominant trait. If that wasn't true, we'd consider it to be recessive. So we've got a dominant trait. Now, at this point, I gave you some additional criteria for under a dominant trait to find out, is it going to be X-linked or is it going to be autosomal? So those next criteria were this. All affected males must have an affected mother. So this male has an affected mother. This male does not have an affected mother. So because he does not have an affected mother, this can't really be X-linked. So by default, we're going to assume that it's autosomal. Now I'm going to go ahead and write that down. This is going to be autosomal dominant. Now, that we know that information, we have to go ahead and begin to label each individual with the correct genotype. So, because this is a dominant trait, I know that all affected individuals have a capital A, because a capital letter is going to represent a dominant gene. And we're going to go with the letter A. If no other letter is given, we're going to go with the first letter of the alphabet, A. So I'm going to go ahead and label every affected individual with a capital A, because I know they must have a capital A or they wouldn't be affected. Now, all unaffected individuals must not contain a capital A, because if they did, they'd be affected. So all unaffected individuals, all unshaded figures, must have 2 lowercase a's. We've now filled in all our given information. So now what's left to do is a little detective work. We have to figure out, what is the second letter? What's the second letter here? And again, it doesn't matter where I begin, just as long as I begin somewhere. Well, let's go ahead. We'll start right here and take a look. So here's some kids, and here's their parents. Now I'm going to kind of zero in on mom here because she's got 2 lowercase a's. And I know mom has to contribute one of those lowercase a's to her kids in all 3 cases. So we can see that there's a capital A here, and mom can't give what she doesn't have. So it looks like dad gave this capital A, but mom must contribute the other letter. And in either case, she's going to contribute a lowercase a. So I'm going to go ahead and write that here, and the same case goes for this. So I'm going to write a lowercase a there. Now let's go ahead and take a look at this individual. This is a male. The parents aren't much help at this point. But if I look at this daughter here, I can see that there's two lowercase a's. Now, each parent contributes one gene or one set of genes to the offspring. That means one of these lowercase a's had to come from mom, and the other lowercase a has to come from dad. So I'm going to go ahead and write that down. And now we've got these two individuals on top. So let's take a look. Now we're going to look at their kids, this daughter and this son. We're not going to look at these individuals. They married into the family, so we can't really use them to determine parent genotypes. So we're going to look at this individual and this individual, and I'm going to zero in on this one right here. She's got two lowercase a's. That means one of these lowercase a's had to come from mom, and the other lowercase a had to come from dad. So both of these individuals are going to be heterozygous. Now, as a final check, what I want to do is I want to make sure each individual has two letters below their name. 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. Just as a final check. If I see two letters there, I know that their genotype has been written down there. And that's going to be it for autosomal dominant traits.